All right, ladies and gentlemen, so we're going to take a look at Chapter 3, Section 2, and we're looking in your textbook on page 182. That's page 182. And we're looking at slope. So just kind of reading through that, slope is a rate of change. It can be positive, slanting upward, or negative, slanting downward. So slope is kind of like the slant of a line. And as you probably learned last year, slope is often referred to as rise over run, or the vertical change. Vertical is up and down, over the horizontal change, and horizontal change is across. That means it is also known as the change in y, because vertical axis is your y-axis, over the change in x, because the x-axis is your horizontal axis. Now sometimes we'll see in math that change is denoted with a little triangle. And that's just kind of an algebraic notation for the word change. So what we're looking at in example 1 is the slope denoted on a treadmill, and the rise over run, you can see, has been filled in for you. The rise is the up and down part, and so they're putting that in there as 10. That's that vertical change. And the run is that horizontal change, and they're putting that in there for run. So rise over run. They reduce that fraction to 5/24, so the slope is 5/24. So we're getting that change, that vertical over horizontal. So if we look at the got it, we have a hiking trail that rises 6 feet for every horizontal change of 100 feet. So writing that out, we have a rise of 6 feet and a horizontal, that's your across, change of 100 feet. What would the slope of that hiking trail be? Remember, you want to think of it as rise over run. Enter your answer on Edpuzzle. Hopefully you were able to look at that as 6 over 100 and reduce that fraction to 3 over 50. The slope of that hiking trail would be 3 over 50. Another way to look at slope is on a graph. So we have in example 2 the graph showing the cost of muffins at a bake sale, and we're supposed to find the slope of that line. When you do that, you can choose 2 points on the line. They've chosen 2 points for us. The vertical change, 2 points, and the horizontal change is 1. That vertical change, remember, that's up and down, that's the change in y, and the horizontal change is across, and that's the change in x. So we're looking at that on the graph, and they've color-coded it. So the change in y, let me change those colors there. The change in y is done in blue, and they're looking at that being up 2 points. So that's the rise of 2. Then they're looking at a change across of 1 point, so a jump of 1. So from 1 point to the other, we go across 1. So that is the run of 1. So the slope of this line is 2 over 1, rise over run. How much did you go up from 1 point to the next, and how much did you go over? In example 3, we have a table that shows the number of pages Garrett has left to read after a certain number of minutes. The points lie on a line. Now it's just saying that it's linear. We've looked at that word before. Find the slope of the line. Choose any 2 points from the table to find the changes in the x and y values. You see the first part of our table is the x values, and the second part of the table is our y values. So looking at that, they're asking you to choose 2 points. Now they just chose the first 2 points. So that's 112 and 39. And so we're looking at the change in y over the change in x. So you see that they take the 9 and 12 in the y values, and they're putting that in the change in y. Then they take the change in x values, and putting that in the change in x. So the formula is change in y over change in x. You probably looked at this last year as a formula as y2, that's the second y number, minus y1, the first y number, over x2, the second x number, minus x1, the first x number. Now those little numbers, the 2 and the 1, are not exponents, they're sub-numbers. So they're just telling you like the first one, second one, first one. Let's look at the got it's together on 183. In B, we have a line, and we're looking for the slope. So we want to look at the change in the vertical, change in y, over the change in x. So we count our run and put it, sorry, let me back that up. We want that to be rise, not run, rise over run. So you want to count the number it's gone up and count the number it's gone over. Reduce if you can. Enter your answer on Edpuzzle. Hopefully you looked at the fact that it went up 3 and over 4. 3/4 can't be reduced, so the slope of that line is 3/4. In part C, we need to use 2 points. So we're going to use, again, the change in the y values. So I'm going to take my second y value and subtract my first y value. And I'm going to put that over my second x value and subtract my first x value. Now you guys know I'm not really a proponent of rewriting subtraction, but when it's minus negative, that's ugly. So we do change it then. And I'm going to take that minus negative and rewrite it as just plus. Minus negative is the same thing as plus positive. Then I'm going to work that out. So I should get my rise over run. Enter your answers on Edpuzzle. Hopefully you got 1 over 4, and that's the slope of that relationship. If we would graph it, we would see that it's a slant of up 1 over 4 from one point to the next. So the last thing we want to take a look at in this section is the slope formula. The slope, m, and that m just means that that's the letter that we use to describe slope. And we'll look more at that when we're looking at equations, but in an equation, you'll see often an equation y equals mx plus b. That m is the slope. And I bet you looked at that a little bit last year. We'll look at it a lot this year. Anyway, it's the ratio of the difference in the y coordinates to the difference in the x coordinates. We're looking at the difference between the rise over run or the difference in the y's over the difference in the x's. It doesn't matter which order you really put the points in. You just have to make sure that whichever ordered pair you start with, that's like 1 and 2, and then the second one is 1 and 2. So you don't want to switch the order that you're counting first point and second point in the formula. But if you keep them the same and follow the formula, you can find the slope each time.